All right, so in this module, we're going to talk about the scientific method. In the last module, we discussed non-scientific approaches to knowledge, and here we're going to talk about the scientific method or the scientific approach to knowledge. We're going to define the scientific method and talk about the steps that are involved in the scientific method. So let's begin with a definition. So the scientific method involves formulating a specific question and then systematically looking for answers by ideally setting up some kind of experiment. And as we'll see, this often involves combining a number of other methods for knowledge acquisition. And so here we can take the scientific method and break it down into 5 simple steps. Well, okay, they're not so simple. But anyway, step number 1 is to observe behavior or some other phenomena. So in psychology, it's probably behavior. In other fields of science, your observations will be about something different. Step 2, form a tentative answer or explanation. This is also called a hypothesis. Step number 3, use your hypothesis to generate a prediction, but not any prediction, one that is testable. And we'll talk more about what that means later in the course. Step number 4, evaluate the prediction by making systematic planned observations, which often involves setting up and running an experiment. And finally, step number 5, use the observations that you derive from this process to support, refute, or refine the original hypothesis. And so then you go back to step 1 and the process begins anew. All right, so we're going to talk about these in more detail, beginning with step 1, which simply involves making observations. Observations of behavior, if you're in psychology, or some other phenomenon, if you're in some other field. And especially in psychology, this is going to be one of the least formal and least structured of the 5 steps. It involves going out there and making observations of the world around you, observations of yourself in the world. Do you notice any patterns? Do you notice any trends? Do you notice anything interesting or unusual? And maybe if you pause and put down your phone and think and observe, maybe things will begin to stand out. So maybe on your adventures of observing these strange primates called Homo sapiens, you notice that we use profanity. And profanity is interesting. To my knowledge, it's found in every language, every culture. And furthermore, there are similarities across language and culture regarding what is profane. What words, what verbs, what nouns, what adjectives typically constitute profanity. So often profanity revolves around certain bodily organs, their functions, their excretions, various sexual acts. This is often the content of profane language. And maybe you notice this. And maybe you notice that people use profanity quite often. And perhaps you begin to wonder, well, what role does profanity play in human life? What are the situations that elicit profanity? And can we glean what is happening in these situations? Is profanity adaptive? Are there benefits, maybe, to using profanity? And perhaps you notice that people are more likely to use profanity in some circumstances more than others. For example, in a bar versus a church, in heightened states of emotion, or when people are in pain. When somebody stubs their toe, certain words are much more likely to leave their mouth than other words, and I think we all know what those words are. And so you say to yourself, all right, there's this relationship between profanity and pain, right? There it is. And maybe this observation can serve as the basis of a scientific study. All right, so then step 2 is forming a tentative explanation, also called a hypothesis. And this begins by identifying variables that relate to your observations. And a variable is simply any characteristic or any condition that can change between individuals, that can take on different values. For example, age, weight, height, income, political orientation, number of swear words used per hour. Any of these can be variables. And ideally, maybe you do some background reading and research on these variables and how to conceptualize them. And then you want to formulate a hypothesis. Now, a hypothesis is, again, a tentative statement. It's a best guess which specifies a relationship between your observed variables. Now, a good hypothesis should lead to a testable prediction, right? A prediction of something that ought to be the case if your hypothesis is true, and a prediction that we can test using the methods of science. And this is typically the starting point of your scientific investigation. So let's look at our example using pain and profanity. So pain and profanity are different kinds of variables. For example, pain can be short and sharp, like a needle prick, or maybe long and dull. It can be self-inflicted or inflicted by somebody else. And then there's swearing. You can talk about the words that are used, how loudly you say the words, how often you say the words, the context in which you say the words. These are all different variables related to your observations of pain and profanity. And so maybe you think about these observations and you do some research and some reading, and you propose the following hypothesis: that swearing changes the experience of pain by reducing its severity. So in other words, when you use profanity, when in pain, it makes the pain somehow easier to bear. Maybe that's your hypothesis. Now, you're not saying that this is in fact the case. You're not making a definitive claim about the world. You are simply throwing out a hypothetical guess about how maybe the world operates. And this is a good hypothesis because it's fairly specific of what you're saying, And there are, in theory, ways of testing that hypothesis. Furthermore, this hypothesis should make specific predictions, and we'll turn to that next. So that brings us to step 3, in which you want to use your hypothesis to generate a testable prediction. So 2 important words, testable and prediction. So you want to begin by asking yourself, if my hypothesis is true, what sorts of things would I observe in the world? What would the world be like if my hypothesis were true? Because one of the reasons that knowledge is so powerful is that it allows us to predict the future, at least to some extent. So what predictions does your hypothesis make? And of course, because this is science, predictions should be testable. So you're going to run some kind of experiment designed to test the predictions derived from your hypothesis. And the results of that experiment should either support or refute your hypothesis. That is what is meant by testable. So then, sticking with our example of pain and profanity, if the original hypothesis was that profanity changes the experience of pain, perhaps by reducing its severity, then maybe one prediction that we can make from this hypothesis is that people should be less responsive to pain when swearing than when not swearing. Or maybe a second prediction is that people should have an increased tolerance for pain when swearing than when not swearing. So it's often the case that one hypothesis might lead to many different testable predictions. Here's an example of 2 that we've derived from our original hypothesis. So when we formed our testable prediction from our hypothesis, that was an example of deductive reasoning. Deductive reasoning, or deduction, involves moving from something general, a general statement, to something more specific that is derived from that statement. Now, conversely, the other form of reasoning is called inductive reasoning. And that is when you move from specific examples or observations to something more general. And so when we formed our initial hypothesis on the basis of observations, that would be an example of induction or inductive reasoning. So again, induction is going from specific observations to a more general statement. And one example is forming a hypothesis from observations that you make. And deduction is when you go from something general to something more specific. An example is forming a specific prediction that is derived from your hypothesis. So step 4 is evaluate the prediction by making systematic, planned observations. And this is where you actually get your hands dirty. This is where you set up an experiment, you recruit participants, and you collect your data that will serve as the substance and the foundation of your experiment. And of course, you want to try to be as unbiased as you can, both in setting up the experiment and also in collecting the data. You want this to be a very rigorous test of the hypothesis, such that if your hypothesis is incorrect, This experiment should be able to ideally reveal that. So in our example of pain and profanity, well, now you have to recruit people for your study, and you have to set up some experiments where people are in pain and they use or don't use profanity. So for the profanity, you have to figure out what words are they going to say, how often will they say the words, how loudly will they say the words, and what about your control condition, the people that don't use profanity? Are they going to be silent? Are they going to say different words that are not considered profane? These are all decisions that you will have to make. And then the other component is that you have to inflict pain onto your participants. And you have to do so in a way that will not cause a permanent damage or psychological trauma. So a good rule of thumb is there should be no blood and no tears in your laboratory. And so how do you do that? Well, one approach that's been used in these kinds of studies, looking at the perception of pain, pain tolerance, etc., is using ice water. So you have people submerge their hands into a bucket of ice water, and you can measure how long they can tolerate the pain before removing their hands. Now, this is a good technique because, one, it's pretty safe. You probably won't cause any long-term damage. Two, probably it's not too traumatic. And three, you have a measurement. You can measure the time that people spend with their hands submerged. How long can they tolerate the pain? Okay, so the time is a proxy for their pain tolerance. Now, luckily, this study that we're discussing has been done. And in this study, they used precisely this approach. They had people submerge their hands in ice water, and there were two conditions. There was a swearing condition, people that said swear words while their hands were in the ice water, and a control condition where people said normal words that are not swear words. And their measurement was how long do people in each group keep their hands in the ice water? What is their tolerance for pain as a consequence of using profanity or using ordinary non-profane language? And now at last, we have made it to step 5. Use the observations to support, refute, or refine the original hypothesis. So now that you've collected your data and analyzed your data and have run the proper statistics, which we'll talk about later in this course, and you have your results, now you want to compare those results against the hypothesis. Were your predictions accurate? If so, your results support the hypothesis. Or were your predictions incorrect, in which case the findings of your study refute the hypothesis. And this may necessitate going back to the drawing board and either scrapping or revising the hypothesis that was originally formed. All right, so for our example of pain and profanity, let's imagine some hypothetical results of the study and talk about how we would interpret those results in the context of our original hypothesis. So let's begin on the left. So here we are plotting time submerged. This is how long people spent with their hands in the ice water. So this is a proxy for pain tolerance. And we're comparing our two groups, the swearing and the no swearing group. So let's imagine that once you analyze the data, you find that people that used profanity, the swearing group, were able to keep their hands in the ice water significantly longer than people who did not utilize profane language. Now, this would support your hypothesis that there is a relationship between pain and profanity such that using profanity increases your tolerance for pain. So this pattern of results would be in support of your hypothesis. Now, let's imagine the following pattern of results shown here in the middle. And so let's say you crunch the numbers, and to your surprise, you actually find that there is no difference between the swearing and no swearing condition as it relates to their tolerance of pain as measured by time spent with hands in the ice water. Now, this would refute your hypothesis because it implies that there is no relationship between profanity and pain. That doesn't matter if you swear or not. It has no impact, at least not on pain tolerance. And finally, let's consider the following possibility shown here on the right. Let's say you analyze the data, and what you find is that people in the no swearing condition actually kept their hands in the ice water longer than people who used profanity in the swearing condition. So this would imply that using profanity actually lowers your pain tolerance, not raises the pain tolerance. So this would suggest that yes, there is a relationship between pain and profanity, but that relationship is opposite of what we predicted. We predicted that pain should raise your pain tolerance, and here we find that it actually lowers the pain tolerance, again, in this hypothetical outcome. And so if we were to find this pattern of results, we would likely want to maybe refine our hypothesis in light of these findings and test the new version of this hypothesis. So what we can glean from this discussion is that science is a cyclical and iterative process, right? So you begin with your observations, you form a hypothesis, you make your predictions, you collect your data, you test your data, you evaluate the hypothesis in light of the data, and oftentimes that will result in a new hypothesis, a refined hypothesis, a version 2.0 of the hypothesis, where the process begins anew and so on and so forth. So this process iteratively refines knowledge through repeated cycles of hypothesis testing, and this is how our knowledge of human psychology gradually expands and becomes more accurate over time and over multiple, many experiments. All right, so just to recap our 5 steps of the scientific method. Again, step 1 is observe behavior. We observed that people often use profanity, and profanity is more likely to occur in some situations over others. Step 2 is to form a tentative answer, also called a hypothesis. And our hypothesis was that swearing changes the experience of pain by reducing its severity. Step 3 was to use your hypothesis to generate a testable prediction. In our case, one of the predictions we came up with was that people who are swearing, who use profanity, will have increased tolerance to pain. Number 4 is to evaluate the prediction by making systematic planned observations. And so we ran this experiment where people submerged their hands in ice water. And some people used profanity and some did not. And we can measure how long they can last in the ice water. And finally, step 5, use the observations to support, refute, or refine your original hypothesis. And so we talked about hypothetical findings in this study and how to interpret each finding in the context of the hypothesis, whether to support, refute, or refine on the basis of the pattern of results. And in the actual study, it was found that people who use profanity actually did have higher pain tolerance, which would support the original hypothesis. All right, so let's discuss 3 important principles of the scientific method, and those are as follows. Science is number 1, empirical, number 2, public, and number 3, objective. So let's begin with the first. Science is empirical, and this means that answers are obtained by making observations. So it doesn't matter if some conclusion appears obvious, or logical, or self-evident. To accept an answer on the basis of science is to ensure that the world actually behaves in a way that is consistent with your theory or hypothesis, and this is done via observations. However, you can't simply rely on ordinary observations. Rather, you have to use structured or systematic observations, which typically requires running an experiment, creating a situation that allows you to test your hypothesis against reality. So in our example, we didn't simply observe people using profanity. We did not just casually ask them how they felt. We ran an experiment. We had a way of measuring pain tolerance. We had a control group. So we compared people who used profanity during pain to those who did not. And the experiment was set up such that the pattern of results could either confirm or refute our original hypothesis. Number 2, science is public, meaning everything you do has to be made transparent to other members of the scientific community and the public, such that people can evaluate your work and know exactly what you did to get your results. You can't have any secrets. You can't ask people to take your word for it. You have to show your work. So scientific studies are published in special peer-reviewed journals, and when you submit a manuscript, you have to have a methods section that describes in gory, intimate detail exactly what you did in your study. Describe the participants. Who did you run? How many people? Describe the actual experiment. What stimuli did you use? What task were people given? How were data collected? What kind of data were collected, etc. And of course, describe your analysis step by step. And nowadays, it's also common to make your data sets publicly available for other people to download and analyze on their own. So by making everything public and transparent, this will allow other people to evaluate the quality of your work, to criticize your study, to make suggestions, and also to replicate your study. So you have to provide enough information where if somebody wanted to rerun your study from scratch, they would have all the information and details necessary to do that. So replication, that is the rerunning of studies that have already been run, is very important to the advancement of scientific knowledge for the following reason. So any one study can produce results that are flawed or incorrect. For example, maybe there's a mistake in the analysis, which can happen very easily, and this produces incorrect results. Or maybe the results are just due to chance. So in the profanity study, maybe it was the case that people in the profanity group just happened to have higher pain tolerance by chance than people in the no profanity group, and it had nothing to do with the swearing. The results were not caused by whether you used swear words or not. Now, maybe this isn't very likely, but unlikely things happen all the time. So any one study can only give you limited confidence in its conclusions. However, each time that study is independently replicated and you have the same results, your confidence in the conclusions goes up. Finally, number 3, science attempts to be objective, meaning when designing a study and analyzing the results, we want to do everything in our power to ensure that the outcome is not contaminated by our own biases. Scientists are human. We have feelings. We may want the results of our study to come out a certain way. It may be advantageous to one's career if the results come out a certain way. However, the fundamental purpose of science is not to advance careers, but rather to try and understand the world around us in as objective a manner as we can. So a classic example of correcting for bias is the double-blind approach that is often used when testing the efficacy of some drug or treatment. So in a double-blind study, the participant doesn't know if they got a drug or a placebo, but also the experimenter who, let's say, may be evaluating the progress that people are making in the study, also doesn't know who received a drug and who received a placebo. This way, any bias that the experimenter might have is effectively neutralized by the double-blind design. And we'll talk more about this design later in the course. All right, so in the last part of this module, we're going to consider science versus pseudoscience. So science is a way of knowing that is characterized by careful, systematic, objective observations of the sort that we described in this module. Now, sometimes you encounter pseudoscience. Pseudoscience is a belief or a system of beliefs that is presented as being scientific while lacking one or more critical components of the scientific method. In other words, ideas or beliefs that don't conform to the scientific method but are presented by the practitioners or believers as being scientific. There are many examples we can go through. Aromatherapy, astrology, intelligent design. These are all examples of pseudoscience. Now, again, I think it's important to specify Just because somebody believes that God created life in the universe, that's not necessarily pseudoscience. It's only when that belief is presented to be scientific that it becomes labeled as pseudoscience, and conflicts and disagreements will begin to arise. All right, so let's talk about some ways in which science differs from pseudoscience. Firstly, testable and refutable hypotheses. So science is characterized by theories that can specify how they can be refuted. So when deriving your predictions from your hypothesis, you should be able to state under what conditions, what pattern of results would support your hypothesis, and what pattern of results would falsify or refute your hypothesis. By contrast, a pseudoscience will often ignore or discount or minimize or explain away negative findings that challenge the ideas in the pseudoscience. Next, objective evaluation of evidence. Science demands unbiased evaluation of evidence, relying on consistent, replicable results. By contrast, pseudoscience may often preference ways of knowing that are less scientific, less reliable, less rigorous. For example, anecdotes or testimonials may be used to support the ideas of pseudoscientific theories. And finally, adaptability to new evidence. Because scientific ideas are falsifiable, because science is open to criticism, it changes over time. Theories change, ideas change, methods change, and as a consequence, science becomes better and better at explaining the world around us. By contrast, because pseudoscience often may be unfalsifiable or ignores criticism and contradictory findings, a lot of its ideas and theories may be kind of old and stagnant and stuck in the past.